For this example, we're given a line that represents the velocity versus time function, and we're asked to find how far the object moves. How far actually says that we need to find the displacement dx, as we know, dx is x final minus x initial, but it's also the integral of the velocity function for a specific period of time between t initial and t final. Now, because the line that we have creates a shape that is easy to find the area under, or the area of that shape, we can, instead of doing an integral, we can do the displacement by finding the area under v versus t line is actually delta x. Does not always happen, but when it does, it's a nice surprise and gift for us. So in this case, if you notice that the area underneath the curve from t equals 0 to 3 is this shaded region, and that shaded region is a triangle, so we know that the area is 1/2 times the base of that triangle times the height of that triangle. And again, this is between 0 and 3 seconds. So 1/2 is 1/2. The base is between 0 and 3, and it has units of seconds. And then the height has a magnitude of 12 meters per second. And if we multiply these, we get 36 divided by 2, or 18 meters. So the car, or the racer, moves 18 meters during the first 3 seconds. Another way we could have done this, it depends on whether you've taken calculus or not, but we're told in the graph that the velocity function is given by 4t, so we know that x is going to be the integral from 0 to 3 of this vt. And opposite to what we did in derivatives, the rule for integration says the following. If I have the integral of x to the n, then I'm going to get x to the n plus 1 over n plus 1 plus some constant, unless I have these limits of integration, which in this case we do. So if I apply this rule here, I'm going to get 4 is a constant, so it just tags along. T to the first is x to the n, so it would be t to the 1 plus 1, or t squared, over n plus 1 is 2. And now because I have the limits, I have to integrate using those limits. So notice this is the same as 2t squared evaluated from 0 to 3. And this vertical line says the following. Take the top value, plug it in, minus what you get when you plug in the bottom value. And notice you get 3 squared, which is 9, times 2 is 18, minus 0, so it is 18 meters, which is exactly what we got before. So Depending on whether you know calculus or if you know the area of shapes, you could have done this one of two ways.